Let's start with the ones you should know already, hopefully. What's the graph of y equals 2 look like? Shh, girls.
Horizontal.
Forrest.
Horizontal line 2.
You go up to 2 on the y-axis, and yeah, it's horizontal, so it looks like that, y equals 2. So what is x equals negative 1 look like? Caden? Yeah, you go to negative 1 on the x-axis and draw a vertical line through it. So hopefully we know those. We're kind of talking about weird function graphs today. Some of them you know, some of them you don't. We did this next one way long ago. Does that look familiar? Ring any bells?
Yeah, I hate that. Oh.
Does anybody know what the graph looked like?
I have no idea.
Okay, if we don't know what a graph looks like, how do we figure out what the graph looks like?
You graph it.
You plug stuff in and see what comes out. Okay, I'm not saying you have to do this every time, I'm just saying this is how you figure it out. So if I plug in like negative 2 for x, what's y going to equal?
2.
Positive 2. So by the way, this is interchangeable, right? F of x equals absolute value of x. It's going to look more like in function notation. Same thing though. The y-axis could also be like the f of x axis. Okay. Anyway, if I plug in negative 1, if I plug in 0,
Oh, it's
1.
It's like the U thing.
All right, you guys remember this?
Yes. It's like it's called a parabola.
Is it a V? I bet it's a V.
No, it's a
not
V.
U.
Okay, negative 2, 2, negative 1, 1, 0,
But
0.
look, it talks about V's. It is a V. Look. I
It's
told you
not a
you
V.
are so no
Bro.
Okay,
Wait, but then what's
It-
What do you mean by that?
It usually.
What do you mean by that? And you
Because
It's not
Because
just
typically-
x equals
typically
y, like
it goes
not the
up like
same.
What's
this.
the but?
Like
It
it's
doesn't
not
say
just
you
straight in the middle.
anywhere.
Okay.
It doesn't say shit anywhere.
guys, what does it look like if I just put y equals x? What's
That's
that?
straight in the middle.
Okay, that would be like a 1 slope with a 0 y-intercept. So that's just a linear equation because it makes a line. It's a linear function. That just looks like this, right? Okay, but the absolute value makes it bounce and go positive again. So it's a V shape. Let's see if you guys remember this. What happens to the graph if I throw a plus 2 out here? Graph goes up 2. Here's the harder question. What if I put the plus 2 directly on the x?
Left two.
Left 2. Yeah. Did we do this last year? You guys,
Yeah.
You're remembering it too well.
I was guessing left or right.
Okay, well, so here's the way I think of it. The x value is the one that goes left and the x value is the one that goes left and right, right? So if you put it directly on the x, it affects the left and right, but it does the opposite of what you might guess. Plus 2 actually moves it left 2. Because everything happens 2 quicker, like 2 to left, but. So this would move it left 2, and like if I threw that out there, down 1. So it would look like that. Whoa. Not like that. Not like that. Like this. Left 2, down 1. Do you guys remember what this point down here was called? Vertex, yeah. And do you remember what this graph made? That's from Mel.
Going
Yeah.
upside down.
It's, well, that would be like this. And
That's right.
it's called a parabola.
That's what I was talking about.
And this is also that's also the vertex. Okay. Yeah. So that stuff, it's been a long time since we did that, right? But it's kind of some of the stuff. Now there are 2 new things that we're doing. And the first one is is challenging. I'm going to steal it from the book though, because I don't want to make one up right now. Okay. This is called a piecewise function. So it's kind of like multiple functions hooked together on the same graph, piecewise. Okay, so the function equals x plus 3 when the x values are less than -2. So that's like, well, what does the graph of y equals x plus 3 look like? I don't know. I'm going to squeeze it over here. Yeah, it's a line, right? Because it's got a y equals mx plus b form. So 3 is the y-intercept, and the slope is 1. All right? Okay, whatever. So it normally looks like this, right?
Yeah.
But here's the problem. This is only supposed to apply for x values less than -2. Well, what's that mean? Where are the x values less than -2? Well, the x-axis is kind of like a number line, right? 1, 2, -1, -2. So these are the x values. So x values less than -2, it's really just all the values over here. So this part would not be part of the graph. And this, at -2, should be an open circle. Why is it an open circle right there? Because it says x is less than, but not equal to -2. So we would just graph the left part of that. Does that make sense? Okay, and then when it says for x values between -2 and 2, x is greater than or equal to -2, smaller than or equal to 2. Between these two, so like that would be like from here to here, we're supposed to graph x squared. Well, what does the graph of y equals x squared look like? Looks like a U, we kind of talked about it. But if you're not sure what it looks like, well, we're going from -2 to 2, right? So let's plug those in. What's -2 squared? 4. Darn it. What's -1 squared? 0 squared. 1 squared. 2 squared. So it's -2, 4. 2, 3, 4 right there. -1, 1. Why did I make that solid? Because it's equal to, it's including these 2 points in it. So these are going to be solid. 0, 0, 1, 1, 2, 4. You guys remember how these were symmetrical. Now it doesn't keep going up forever like normal. It just stops right there. And then once we get to 2 for the x value, from 2 to 5, we're supposed to graph 1. What does that mean? Well, it means like f of x equals 1 or y equals 1. What's that graph look like again? Yeah, it's a horizontal line. So from 2 to 5, 3, 4, 5, we're going to graph y equals 1, a horizontal line. So at 2 it would not be included, but at 5 it would be. It's just a horizontal line. Okay, so it's like putting 3 graphs together at once. From here this way, it's this graph. From the middle, it's this graph. And you guys see how it works? It's just different graphs stitched together to make one funky looking graph.
Is piecewise gonna be on the test?
Yeah, 10 piecewise questions on the test.
You're joking.
He says pulling your hair.
They're not smart guys.
Just need to brush it.
I don't know. I'm not gonna say one way or the other. Just don't. Okay, there's one more. This one's not as bad. One more function we're talking about. This one is called. It looks like this. So it's kind of weird looking. It's called. They call it the greatest integer function. I'm not sure that's the best name for it, but you guys remember what integers are? Function, singular. It's like -3, -2, -1, 0, 1, 2, 3. Yeah. So basically what it does is whatever you plug in for x, like if we plug in 1.4, what it's it's gonna spit out, it's just gonna round it down to the next lowest integer. So this will spit out a 1. If you put 1.4 in for the x, what it'll equal is 1. So, I mean, if I wrote the whole thing out, f of 1.4, you do this thing to 1.4, it just equals 1, okay? Alright, what if I plug in what if I plug in like 0.7? What would that round to? Next lowest integer, 0. Okay, what if I plug in f of 2? 2, yeah, just stay there. Okay, this is where people get it wrong. What if I plug in f of negative 1.3? What's below negative 1.3? Negative 2. Negative 1 is actually above negative 1.2. So if you're rounding down. Okay, so anyway, that's how it works. It just rounds it down to the next integer. And on the graph, it looks like this. I'll try to explain why. Maybe I should zoom in a little bit. And it goes forever. It's a stair step. Because if you plug in x of, let's say, 1.5, or, well, I kind of wrote it up there. If you plug in 1.5 for x, the y value goes down to 1. So it's like 1.51. Or if you plug in negative 1.4, that rounds down to negative 2. Negative 1.4, negative 2. You guys kind of get it? But that's what the graph looks like. It just goes forever in both directions. Stair steps like that. There's a picture of it on the bottom of 83. Looks a little bit prettier than mine.
It is pretty.
Mine's gorgeous, I know. Alright. So we got the piecewise and that thing. Those are the two new weird ones. Alright, number 1, these are matching. We're supposed to say what kind of function it is. Y equals absolute value of x. So what kind of function is number 1? Absolute value. So it's 1a. Number 3. Okay, I just named it. If I scroll down a little bit, it'll be up there, but greatest integer function. So that is C. Number 5, y equals x. What does that look like if we graph? Right, it looks like a diagonal line, right? We talked about that, so that would be a type of a linear function. If it looks, let's see, what option is that? D? Okay, number 6, I probably better talk about this one. What kind of function is this? Well, what does the graph of x equals 2 look like? Vertical line. Okay, is that a function? About a week ago we talked about what makes a function a function. Does it pass the vertical line test? No. So 6 is actually not a function because it fails the vertical line test. So yeah, East was right. Okay, numero 7. State the domain and range of each piecewise. Okay, do you guys recall what domain was from last week?
All the somethings.
Yes, all the somethings. All the whats? What is this? Huh? X values. Domain is the possible x values you could use. So on number 7, you remember how we did this? We start with the smallest x value, which is the farthest to the left, to the largest x value, which is farthest to the right. So remember, x values go left and right. So what is the smallest x value on number 7? So how far left does the graph go on number 7? -6, almost to -6. Because that's an open circle, -6 will not be included. Therefore, it's x is greater than -6, but not equal to. Okay, and then if you go to the right, if you move to the right, every x value is filled in until you get all the way to the right. How far right does it go? 2. The far right point has an x value of 2, so that's the largest x value. Is 2 going to be included?
Yeah.
Yes, because that dot is filled in the picture, so it's less than or equal to. Okay, then the range would be the what? The y values, right? So that's up and down. So it's kind of the same thing. What is the lowest y value on number 7? How low does it go? -3. Is -3 included?
Yes.
Yeah, it looks like it's touching at -3, so I'm going to put -3 less than or equal to y,
6.
and it goes up to 6. Is 6 included?
Yes.
Yeah.
Let's go.
Caden's pumped. Are you guys pumped?
Yeah.
Number 9. Okay. Same thing. What's the domain? So this one's a little bit weird because not all the things are connected. But if you're looking from left to right, are all the x values filled in from left to right? Yeah. So the domain is not going to be too weird. The range, however. So what is the smallest x value on number 9? How far left does it go?
Less than negative.
Yeah.
Greater than negative.
Right, just like last time, it goes all the way out to -6. And -6 is not included because it's an open circle. Then what's the largest x value? How far right does the graph go? Positive 3, and that one is included. So I'm going to put less than or equal to 3. Do you guys remember what I told you the other notation was? Probably not. You could write the same thing using this notation. I mean, it's the same thing. You might see that someday. Maybe if you take college algebra or something. Okay. I kind of prefer this one actually, but our book does this one. We'll stick with it. All right, the y values. So what's the lowest y value on number 9? Yeah, the lowest y value is at 1. Maybe let me, probably help if I graph this one. It goes -6, 1, and moves over like 3, 1, 2, 3, 4, 5, 6. Like that, right? Or, yeah, that's right. And then it goes, does it go to 3? Yeah. Okay. All right, here's the problem. Going from here up, are all the y values filled in? So I can't just say y is from 1 to 4, because not all those y values are included. From 2 to 3, those y values are not included, and from 3 to 4, those y values, there's nothing in there. So I have to say the y values from 1 to 2, those are all filled in, right? So the y values from 1 to 2 are filled in. That's part of the answer. there are no y values from 2 to 3, but there is a y value at 3. You guys see where I'm getting this? So I'm just going to put y equals 3, comma, what other y value is included? Y equals 4. Okay, so it's not a continuous set of points. This set of points is continuous. Then we just have y equals 3 and y equals 4. So that's the range. Fortunately for you guys, that was the only weird one in that group. Hopefully that made sense though. All right. And then the next section, evaluate each function for the given values. Okay, it says f of x equals 5. That's our function. What's this the same thing as? You know, it's like y equals 5, right? Okay, so the question is, what is f of 3 and f of negative 1? It's kind of weird. Anybody think they might know? So f of 3 means what's the function going to equal when we put in 3 for the x? Well, there's no x to put 3 into, so guess what that means? The function value is just always going to equal 5, no matter what your x value is. So f of 3 is still going to equal 5. Does that make sense? Normally there's an x where you can plug something in, but on this function there is not x to plug in. So f of negative 1 is going to equal 5. Function always equals 5. Okay, 13. What did I call that thing? With the brackets. Greatest integer function, yeah. And what did it do though? That's more important question.
Rounded to the closest.
Rounded, yeah, it doesn't round to the closest integer, it rounds down to the next lowest integer. So, if I have h of, what is it, negative 3.2, you put negative 3.2 in this little bracket thingy, what's that going to turn into? Negative 4. Negative 4 is below negative 3.2. And the other one is 7/4. What's 7/4 as a mixed number or a decimal? Yeah, 7 divided by 4 is like 1 3/4 or 1.75. So if we're rounding it down, it's gonna turn into 1. Okie dokie. Kind of the same thing on 15, but what's the difference? Okay, before we round it down, we're going to have to subtract 0.5. Before we round it down, we're going to have to do x minus 0.5 and then round it down. So we're supposed to do g of negative 1.5. That would be, whoops. Okay, what's negative 1.5 minus 0.5? Negative, yep,
2.
negative 2. And if we round negative 2 down to the next lowest integer, negative 2. Yeah, if it's already an integer, just keep it there. Okay? And the next one they want us to plug in is 5/4. Might be the easiest way to do this one probably is what's 5/4 as a decimal? Or if you don't know what it is as a decimal, how would you figure it out? 5 divided by 4. But you guys probably know this. What's 5 divided by 4? 1 with the remainder of 1. So it's 1 1/4 or 1.25. So what's $1.25 minus 50 cents? 75 cents. And if we round it down, because the greatest integer, 0.75 rounds down to 0. You guys are ahead of the other class because of the graphing, because of the chapel.
When is that?
Yeah.
Dude, my eyes are struggling to see. Man. Keys to solve it.
Yeah, we'll stop there. We are still gonna graph, but we'll start that tomorrow. We'll start graphing tomorrow.
Are they 4 hours? Are they 5 hours?